In this video, I'm going to talk about delta connection. So before going to the delta connection, I'll give a small recap of the previous video. In the previous video, we talked about Y connection. So Y connection is going to look like Y. So that's the reason we call this as Y. Okay, or write it as WYE, same as Y connection. Okay, here I always follow the clockwise direction, A, B, C. So here, if you look at this round and a sinusoidal waveform, that indicates a generator. Here, a coil also indicates generators because a generator is nothing but it has number of coils inside it. When it comes to the load, usually you will see ZAB or ZAN, ZBN or something like that. Okay. For generator, I always use the capital letters. So A, B, C. This is called positive phase sequence. I'm going in the clockwise direction. I explained about positive phase sequence in the next video. When it comes to the load, usually I use small letters A, B, C, and most of the textbooks uses the same scenario. So whenever you see small letters, you can assume whenever you see small letters, though, that indicates for the load. I mean, do not define whether it is a load or source by using these letters. Define it by using the current direction. If current is going out, that is this is a source. Okay, for a source, current is going to go out. If current is coming in, then that is a load. That's how you define whether it is load or source. Now we know that this is the phase current IPH, and that's the line current because this is the line, and same thing, this is IPH IL. Okay, and this is VPH, and this is valid for both as source as well as load, VL. So the important points you learned from the previous video: IL equal to IPH. In Y connection, IL equal to IPH, and VL equal to √3 times VPH. Okay, so the line voltage is bigger than the phase voltage. You can see, I mean, always like this is the line voltage, it's longer than the phase voltage. So that's how I remember when I was a student. VL equal to √3 times VPH. Please review my previous video how I got those numbers. Another important thing is VL, line voltage, leads phase voltage by 30 degrees. This is also true as long as it is a Y connection. Doesn't matter whether it is a source or load. I mean, it's always line voltage leads the phase voltage by 30 degrees. And P, power equal to √3 times VPH IPH cos theta, where theta is angle between VPH and IPH. P equal to, or 3 times VL, my apology, I put in the reverse side, P equal to 3 times VPH IPH cos theta. Okay, or P equal to √3 times VL IL cos theta. Okay, so this theta is still angle between VPH and IPH. You can use any one of these formulas. So when it comes to the Y connection, immediately you need to remember all these points. Okay, for Y connection, IL equal to IPH, VL equal to √3 VPH, VL leads VPH by 30 degrees, and P is 3 times VPH IPH cos theta, or √3 times VL IL cos theta. Here is the delta connection. Okay, so a delta look like a delta. So here you can see a winding is indicating the generator. Okay, so we have 3 single phase generators, or maybe 3 coils connected in a single generator. So it's a 3-phase generator. They are connected in delta. Now, this winding is called phase. Okay, that winding is called phase. So this is phase A, phase B, phase C. So you can see I always follow the clockwise direction, A, B, C. Okay, A, B, C. I'm going in the clockwise direction. Now this is phase and this is line. Okay, whatever going out of the phase or out of that junction is called the line. So the phase voltage here is VAN. Okay, VAN. So the voltage across this phase. Can I say my VAN is same as the voltage at this point and the voltage at this point? Isn't it same? That must be same, VA, and voltage at this point and voltage here must be VB. Okay, so I can clearly see my VAN is same as VAB. The voltage between these 2 points and voltage between these 2 points are same. So VAN equal to VAB. So basically this is phase voltage, okay, and this is line voltage. So in delta, phase voltage equal to line voltage. So that's one important point. Whereas in star, line voltage equal to root 3 times phase voltage. Now when it comes to the current, okay, so here I have every current is going in out, right? So this is the line current, I line. So the phase current here, say this is going out and this must be coming in, because every current is going out of each phase. Okay, so this is IAN, this must be IBN, and this must be ICN. Okay, so IAN is going out, IBN is going out of the phase, ICN is also going out of the phase. So the here at this point at junction A, at node A, ICN is going out of the junction, I line is going out of the junction, IAN is coming into the junction. So if I say IAN equal to take some number I at an angle of 0, or I1 at an angle of 0, or IA at an angle of 0, and IBN must be IB at an angle of minus 120 degrees. Okay, and ICN must be IC at an angle of minus 240 degrees, because each phase is physically kept 120 degrees apart. So that's the reason IA, IB, IC are 120 degrees apart. So at node A, apply KCL. Apply KCL. If I apply KCL here, you can see IL equal to, okay, IAN minus ICN. IL equal to IAN minus ICN. So if you apply KCL, I line equal to IAN minus ICN. So this is IA at an angle of 0 minus IC. If it is a balanced circuit, IA, IB, IC, all of them are equal. So IC, I can say IA at an angle of minus 240 degrees, because magnitudes are same. IA equal to IB equal to IC. I'm assuming it is connected to a balanced load. Balanced load means each branch of the circuit, three-phase circuit, has the same amount of impedance. Okay, so IA must be equal to IB, IB must be equal to IC. So if you solve this, convert this into, if you want to take this as a magnitude 10 at an angle of 0 minus 10 at an angle of minus 240, and convert this polar format into rectangular, polar into rectangular, and you will find I line equal to square root 3 times I phase. Okay, this is the important point. Another important point is I line lags I phase by 30 degrees. So when you solve this, you will see the difference 30 degrees. I line lags I phase by 30 degrees. That's another important point. Now the third one is power. Power equal to 3 times VPH IPH cos theta, where theta is angle between VPH and IPH, or P equal to root 3 VL IL cos theta. So from delta we learned that V line equal to V phase. That's one important point in delta. Okay, this is a delta connection. It doesn't matter whether it is source or load. Okay, so VAB is a line voltage, same as a VBC, okay, and VCA. Okay, so V line, magnitudes of V line equal to VPH. Now I line equal to root 3 times IPH, and another thing is I line lags IPH by 30 degrees. That's another important point. And P equal to root 3 VL IL cos theta, or 3 times VPH IPH cos theta, where theta is the angle between VPH and IPH. I'll stop this video here. In the next video I'll start solving an example based on the Y connection and delta connection. Thank you.